Hey guys, Brian here from Bright Guy Garage, and in this video we're going to be taking a look at micrometers, how to zero them, how to read them, and how to measure with them. Let's take a look. So, what is a micrometer, who uses them, and why? Micrometers are used to take a very precise measurement of the outside diameter of an object. Someone that might use a micrometer would be a mechanical engineer, a machinist, and even some other tradesmen that need really precise, small measurements. So I have a few different measuring tools here that I'm sure we've all seen before. We have measuring tape. This would be great if I needed to cut a piece of wood down to 11 3/8 of an inch. Here I have a pair of calipers. This would be great if I needed to, let's say, shim the torque converter in my transmission and I needed to shim it about 0.137 of an inch, let's say. I can put a washer stack in there and keep adjusting the stack until I get 0.137. Calipers, great for that. They'll get you close enough. Anything beyond that is where the micrometers come into play. These take very, very precise and small measurements, and they do it with accuracy and repeatability. So let's just show a quick example of why using the right tool matters. So let's say I want to measure the #1 main journal here on this crankshaft out of my Oldsmobile V8. If I use a pair of calipers, which I zeroed, and I come in and I set this over the main journal, get it on there pretty square, and tighten it up, we can take a look, and the calipers are showing 2.4955, if I'm seeing that correctly. Now I've measured this already with a micrometer, and that measurement, main journal outer diameter #1 is 2.4878. So we can see that that is close, but is, in the terms of machining tolerances, way off. So it's very important to use the right tool for the job. Micrometers are sold in inch increments. So for example, this is a 0 to 1 inch mic, this is a 2 to 3 inch, this is also a 2 to 3 inch, and that is a 4 to 5 inch mic. So depending on the size of what you need to measure, you need to use the appropriate micrometer. So on my crankshaft that we were just looking at, the main journal measured about 2.48 of an inch. So we would want to use the 2 to 3 inch micrometer to measure that. Additionally, if we were measuring something that was about 4 3/4 of an inch, you would need the 4 to 5 range mic. So you need to pick the appropriate mic for what you need to measure. Additionally, you need to take into account what decimal point your measurement needs to be taken down to. So, for example, these two micrometers are both 2 to 3 inch micrometers. However, this top one only reads down to 1/1000th of an inch, whereas this bottom one reads down to 10/1000ths of an inch. So again, using that crankshaft as an example, where 10/1000ths of an inch really could make a difference, this is not the micrometer I would want to use. I would want to use this one. I want to measure down to those 1/10,000th of an inch. Now let's get in for a real close look at the various parts of the micrometer. This is obviously the body. Here we have the anvil. Here we have the spindle. This is the lock. This part is the sleeve. This is known as the thimble. And this is the ratchet. Also, this is known as a standard. This is used to zero and calibrate your micrometer to make sure it's going to read properly. More on that in a little bit. Next, let's look at the numbers that we find on a micrometer so we can learn how to read them properly and take accurate measurements. We come in close here and look at this 1/10,000th of an inch micrometer. We're going to see 3 scales. Here, our first scale is on the sleeve. This is our reading line, this horizontal line here. These are the sleeve numbers. This is the thimble. I'll refer to these as the thimble numbers. And lastly, we have up here on the sleeve the vernier scale. So there is a particular order in how you need to read a micrometer, and it goes as follows. First, you'll look at your sleeve number, then you'll look at your thimble number, and if you're measuring down to 1/10,000th of an inch, then you look at your vernier scale back here. So again, if you need to read down to 1/1000th of an inch, you would read the sleeve, and then you would read the thimble, and you're done. If you're reading down to 1/10,000th of an inch, you would read the sleeve, then you would read the thimble, and then you would read the vernier scale, and then you're done. So let's break down each of these scales and learn how to read them. Taking a close look at the sleeve here, these are the sleeve numbers, 0, 1, 2, and all of these hash marks that you see here. Let's move over to the illustration because it's much easier to see. So these sleeve numbers, once again, 0, 1, 2, and all the hash marks. Every hash mark represents 25 thousandths of an inch. That's 0.025. So starting from 0, and we have 0.025, and 0.050, 0.075, and then 0.100. This is the first scale you're going to read anytime you read the micrometer. The main thing to take away from this scale is that each of these lines represents 25 thousandths, 0.025. Next up after the sleeve, we have our thimble scale. Each hash mark on the thimble represents 1/1000th of an inch, 0.001. And this ranges from 0 all the way around to 0 for a total of 25 thousandths in one revolution. So again, this line here will be our reading line. That is the line we refer to when we read our measurements. So right now, that line lines up with 1/1000th on the thimble. And let me spin it here. So for example, that would be 4 thousandths, 5 thousandths, 6 thousandths, and so on. The main takeaway here from the thimble scale is that each hash mark is 1/1000th of an inch, 0.001. And lastly, we have our vernier scale here. Each one of these hash marks represents 1/10,000th of an inch, 0.0001. So for example, the 2 here would be 0.0002, 0.0003, 0.0004, and so on. So this is what we learned so far. To read down to the 1,000th of an inch, you read the sleeve, and then you read the thimble. To read down to 10,000th of an inch, you read the sleeve, the thimble, and then the vernier scale. And the sleeve increments are 25 thousandths, the thimble increments are 1/1000th, and the vernier scale 1/10,000ths. So for our first example measurement, we're going to use the illustration here because it's just super easy to see. So again, we're going to start with the sleeve. And we know that each increment on the sleeve is 0.025, 25 thousandths. So that would be 25, 50, 75, 1, 125, 150, 175, 2, 225, 250. So that's this reading here on the sleeve alone is 0.250. So we're just going to take that and write 0.250. That's our first reading from the sleeve. So then, now that we have the 0.250 from the sleeve, we can come to the thimble scale here. And we can see that the reading line, again right here, that line, is between 5 and 6. We never round up. We always use the number below the line. So this is reading 5 thousandths. So we can come over here, and the thimble scale is showing 5 thousandths. So right now, our measurement is 0.255. If we add 0.250 and 0.005, we get 0.255. So if we wanted to read down to the 1,000th of an inch, 3 decimal points, you would be done. your answer, your measurement, would be 0.255. However, if you want to read to the fourth decimal point to the 10,000th of an inch, now is when you look at your vernier scale. And to read that, you find which one of these numbers lines up with a corresponding line on the thimble the closest. See, we look at these lines. This one's above, that one's above. So is that one. That one's way off. That one's off. That one's close. That one's a little off. And actually, now that I repositioned it, I see that it's the 8 that we want. That number 8 line on the vernier and the thimble line up perfectly. So that means it's 8/10,000ths of an inch. So now we can come over here and we can write 0.0008. Now our final measurement would be 0.2558. That is how you read your micrometer. Now that you have the reading off of your micrometer, you'll have to remember which micrometer you're using. So this is the 2 to 3 inch micrometer. So obviously we're measuring between 2 and 3 inches, and the value that we're getting between those 2 and 3 inches is 0.2558. So that means that our total measurement is 2.2558. That is our final measurement. So now that we've learned how to read the illustration, let's actually read the micrometer. So again, starting with the sleeve, we can see that the highest visible number here is the 3, so that's 0.300. And then we have one hash mark showing, so that's 0.325. And then we come over to the thimble, and we have 10,000ths. So between the sleeve and the thimble, we have 0.335. That's 0.325 from the sleeve, in addition to the 10,000ths from the thimble. So 0.335. Now, if we take a closer look here, we can see that the reading line is just a little bit above the 10,000ths. So we can take this measurement down to 10,000ths of an inch. So again, remembering we're at 0.335 between the sleeve and the thimble, we can now take a look at the vernier scale over here, and we can see that the 2 lines up with the vernier scale and the thimble. So that would be 0.3352, meaning our total measurement there would be 2.3352 because we're using a 2 to 3 inch mic. Now this one I'm going to have you figure out. Remember that we're going to start from the sleeve, then the thimble, and then the vernier scale if necessary. So this one was a little bit of a trick. If we look here at the sleeve, we're at 0.500, and we're smack on 19 thousandths. So this would be 0.519. And since we're right on that line for the 19 thousandths right here, if we were reading that down to 10 thousandths of an inch, that would be 0.5190. So no additional reading needed on the vernier scale. And again, 2 inch mic, so 2.5190. Congratulations, you now know how to read a micrometer. However, your readings don't matter at all if you do not have your micrometer zeroed and calibrated properly. To zero your mic, you're going to need the mic, obviously. Then we're going to need the standard and this little wrench. These usually come with your mic. So before I even bother attempting to zero out this micrometer, we're going to first take a lint-free shop towel, and we're going to wipe down the anvil, the spindle, and both sides of the standard. Because if there's any dirt, debris, or even a little bit of grease or oil, that can add a little bit to your measurement. So make sure that all of these parts are clean and that your working area is clean. Okay, now that everything's clean, we can take our 2-inch standard and we're going to get it here in between the anvil and the spindle. And I'm going to press the standard into the spindle a little bit, just hold it there as I rotate the spindle. And if I didn't mention it before, the micrometers usually have this little ratchet here on the end. And when you're taking your measurement, you're going to want to turn it by the ratchet and not actually from holding the thimble. The ratchet will stop once it gets to a certain resistance or pressure on the micrometer. And that will ensure that you get consistent readings, because it is entirely possible to put this standard in there or even measuring a part and turn it by the thimble, and you can really wrench down on that, and that will add to your measurement, or actually subtract if you're tightening it, but it will give you an inaccurate measurement. So you don't want to turn it by the thimble when you're getting close. You want to finish your measurement off by turning it from the ratchet until you hear the... All right, so now I'm going to come out from behind the camera and actually do this down here where I can see and move a little better. So again, with the standard pressed up against the thimble, we're going to get close. Then I'm going to switch my hand over to the ratchet. And now that we hear the clicking and I can see that that's good, I'm going to turn the lock so we don't lose our measurement. So with this locked, we can come up here and take a look. And we can see here that we're ever so slightly off. That 0 is just a little bit underneath the reading line. So we're going to adjust that so that that is dead on. In order to adjust this, we're going to grab that wrench that came with our kit. And if we turn the micrometer over, we see this little pinhole back here. What you want to do is get the little hook end of the wrench into that hole. And now you can basically use that to turn the sleeve, and that will adjust the positioning of your number. If we look here, we can see I moved it even further away from 0 because I'm turning it that way. So we need to come back up this way, put it in like this, and turn this towards me. This is going to be very hard for me to do while looking through the camera, so I'll probably just do this off camera and line it up. Pretty close. Now this may look close to you at first, but remember, this is a micrometer that reads down to 1/10,000th of an inch. So we need to look at the Vernier scale as well here. And for this type of micrometer, with these types of scales, we actually want this 0 to line up, and on the Vernier scale, we want that 0 to line up with a line on the thimble. So it took a few tries, but now if we look, that 0 is pretty much spot on. And if we come up to the 0 on the Vernier scale, oh, I'll turn it back a little bit. We are pretty much bang on with that too. So that micrometer is zeroed and ready to measure. Another important thing is while you're reading the micrometer, make sure that you're parallel and your eyes are even with the reading line, as well as the Vernier scale when you're looking at it, because you might hold this just a little bit off and catch it from the wrong angle. So make sure you're looking at it directly. Additionally, I threw the standard back in there just to double check that I zeroed it out correctly and that we're still bang on the zeros. So we're good there. And the 0 is also a good tool to get used to the feel of when you have a part tightened in there just right. So again, we're going to use the ratchet for most of that, but it's good to know because sometimes you might catch a part a little bit on the wrong angle, and the ratchet will engage too early. So you want to be able to kind of feel your part and feel how the micrometer feels sitting on the part. And you'll know if it's a little too loose or a little too tight, and you might need to adjust your positioning. So the standard is a good tool to use for that. As you can see, I can still spin it, and I can still very easily just slip it right out. So it's not too tight, it's not too loose, and that's exactly what you want when you're measuring with a micrometer. And before we take our first measurement here, there's one very important thing to remember, and it's that we want both our micrometer and the part that we're going to be measuring to have been acclimated to the same temperature for quite some time. So for example, I would not want to have just brought this crank in from sitting outside in the sun for 3 hours into the garage and then take the micrometer out of the drawer in the garage, which is at a very different temperature, and then take a measurement. The crank having sat in the sun for 3 hours, it's going to have expanded a bit due to heat, versus the micrometer that's been sitting in here in a 70-degree garage. So you want to make sure that both of your parts have been sitting in the same temperature environment for quite some time. I'd say leave them overnight in the garage, shop, whatever, and then take your measurements. So now that we understand what a micrometer is, its parts, how to read it, and we have it zeroed in, we can actually go ahead and measure something now. So I'm going to measure the #1 main journal here on my crankshaft. And it's important that when you use the micrometer, you're on flat surfaces. So if I sneak the camera back here a little bit, we can see that I have an oil feed hole right here. I don't want to measure near that. I want to make sure that the anvil and the spindle of the micrometer, that those surfaces stay away from that oil feed hole, because that can throw the measurements off. So I'm actually going to measure it more like this. There's quite a few oil feed holes in this #1 main journal. So now the next thing is actually getting the micrometer centered on the piece that you're measuring. Because if I were to come off center just a little bit and tighten it down, that's actually not centered. I'm going to get a smaller outer diameter reading. So you want to find the point at which you have the micrometer open just enough to slide over the highest point of what you're measuring. So for example, right now I started a little tight, a little on the tight side, and if I try to bring the micrometer over, it's not making it. So I'm going to loosen it a little bit. You can see it's starting to come over, and now I can come all the way over it. So I'm feeling a little bit of resistance right about here. So that is most likely the highest spot of this journal, the largest outer diameter measurement, which is what I want. So now that we're there, I'm going to back it off just a little bit. Now we're going to switch to the ratchet, and we're going to ratchet that down. Don't move the micrometer yet. We're going to lock it so our reading doesn't get messed up. And then we're going to take the micrometer off. Now this is another thing that you will learn the feel for, that with this locked, see how I can still easily move this around? It's not to the point that if I let go, it's just going to fall off, but it's very close to it. And that's what you want. Again, you don't want it too loose, you don't want it too tight, because then you'll have an improper reading. Let's come in and take a look at our measurement. Again, starting on the sleeve, last number visible is 4, and then we got 1, 2, 3 hash marks, so that's 0.475 on the sleeve. Go over to the thimble, that's 10, 11, 12. So 0.475 plus 12 thousandths gives us 0.487. And then we're going to look here on the Vernier scale, and it looks like the 7 lines up pretty good. So that's 0.4877. This being a 2 to 3 inch mic, that gives us 2.4877. And I can go ahead and grab this paper from the measurements that I took earlier. Connecting rods, main journal, outer diameter number 1, 2.4878. Okay, so my measurement that I took just now was off by 1/10 of a thousand. That actually gave us an opportunity to see something that you can definitely learn from. That was off by 1/10,000th of an inch. So sometimes that's user error, sometimes it's just inconsistencies with the part that you're measuring. So for example, this crank was in an engine that was failing. So there's quite a bit of grooves on this journal. It's pretty beat up. So I took the micrometer and measured it in a few different spots along the circumference of the journal. And I kept coming up with that 1/10,000th number being between 7 and 8. So I'm going to say that is the crank journal to blame and the wear. But it's also very possible that you get something like that and it's due to user error. So just keep checking your part and check it in different locations and make sure that you're coming up with a similar number. Or your part could be out of round. A whole bunch of different things can be the cause of something like that. But for this case, 1/10,000th of an inch, that's nothing, and I am not at all concerned about it. All right, guys, this about wraps up the guide on micrometers. Hopefully you were able to learn what a micrometer is, how to read one, how to zero one, and how to measure with one. The biggest hurdle that you're probably going to come across is learning the feel when you're measuring a part and just knowing that it's just right and not too tight or not too loose. But don't worry about that. You'll get that down. That'll come with time and practice. All in all, guys, these micrometers here, these are from Amazon, and they're priced great. I've used them on the engine build for this Camaro, on the Oldsmobile V8 I'm working on, and on another friend's Chevy crank that needed to just be double checked, and some other things as well that I'm not even remembering. But they work great. They've been consistent and they've been reliable and precise. So a professional machinist is probably going to laugh at these, but I'm in the garage here doing stuff on my own. So I don't need professional machinist equipment. So if you're in a similar situation, you're just trying to learn, you're trying to get the job done, go with these. They're not going to let you down. So I'll leave links in the description for that below. But again, guys, I hope this helped. It's really not difficult. You can do it. As always with every video on this channel, that is my main goal to show you guys, is that you can do it. So hopefully you guys are walking away with that, as well as a little bit of information about these. So thank you so much, guys. Give me a like and a subscribe if you like the content. And as always, take it easy.